of you are have a lot of experience in investing already. Our kids, when they were little, we gave them, they started with like $25 and said, you can pick something to invest in. And so our son was really into Star Wars. He still is. Star Wars was owned by Disney, so he decided to invest in Disney. Our older daughter, so he took his $25 and he bought as much Disney as he could buy with $25. Our older daughter loved Starbucks, and so she decided she was going to invest in Starbucks. And so some of you maybe got the chance to do that, or you did it for fake in economics with Mr. Baker, or you'll do that when you take economics in the future. Do any of you have an investment of your own? Any of you made any? Nobody owns any stock? All right, now's the time to do it. Yeah, Sam, you do? Yeah? In what? You own stock in Ferrari? So when did you get that? No? Okay. All right, so your own investment. All right, how often do you track whether it goes up or down? Yeah, okay. All right, so that's what we're going to talk about today, is how the math on how those investment works. So a couple of vocab things that you need to understand. Okay. All right, it's not a word we use very often, but it's the word annuity. When you see that word in your math homework tonight, it means an investment. Okay, an annuity or an investment. This is your money. And then you're going to take your money and you're going to try and make more money on it. But that's what, yeah. Yes. Okay, contrast that to a mortgage. Another word for mortgage is a loan. A mortgage or a loan is someone else's money, and they are loaning it to you. Understanding that vocabulary is going to help you pick the right formula. So, yesterday we learned 3 formulas. Today we're going to learn 3 more. You have 6 formulas total. You'll get a formula bank on your quiz on Friday. The formulas will just all be mixed up in that formula bank. You just need to know which is which. All right, here are the first 2 formulas for today. I'm just going to give you the formula, and then I'll explain to you what all the different letters mean. FV equals R, capital, not lower. There's a difference. Parentheses, small parentheses, so it's a double, which is going to be important in your calculator. You have to put both of them there. 1 plus R over K, which you've seen 1 plus R over K before, to the KT. So that part of it looks like one of the formulas we did yesterday. Minus 1, and your parenthesis. So notice in that there are 2 forward parentheses at the beginning, and then there are 2 backward parentheses that finish it through the rest of the equation, divided by another set of parentheses, the fraction R over K. Okay, the other equation is PV. Most of it looks the same. It's got R, not like R like real numbers, but just the letter R. Parentheses. 1 minus, the same thing as the other one. Okay, so do you see how the FV one has the 1 plus R over K in parentheses, and then the minus 1 comes last? In this one, the 1 minus comes in the front, and this has a negative KT power. And that's also over the fraction R over K. All right, so this is why I don't make you memorize them, because they're kind of complicated, but you just need to know which is which. All right, the first one. It has the letter F because it's for the future. That one is what you use for a future investment or annuity. So you'll need to read the question and decide, am I talking about the future? Or like, am I making an investment or an annuity for the future? It's my money and I'm setting it aside for the future. As opposed to P, which means present, not past, but present, current. Not like a present, not like a gift, not like a Christmas present. Present as in not the past and not the future. So present is current, mortgage or loan. So as long as you understand which one to use in which context. Now you know what little r stands for, you know what little k stands for, you know what t stands for. Now you know what f and p stand for. They stand for the future value and the present value. What's the only letter you don't know what it stands for yet?
Capital R.
Capital R, right. The key to both of these things is that you do it on a regular basis. Okay, if you're making a future investment, that you are doing it every month. Okay, if you're setting money aside for an annuity or an investment in the future, the key is that you do it repeatedly. Every month you set money aside, set it aside, set it aside. R stands for repeat. Okay, you're on repeat. Not like on shuffle, you're on repeat. Same thing over and over again. Or with a mortgage or a loan, you're on repeated payments. If you get behind on your mortgage or loan, if you skip one of those required repeated payments, then the interest on that is going to kill you on the back end. So that's what R stands for. Okay, so this R stands for repeated payments. Now you are either paying yourself, which is what an investment or an annuity is, because you're paying yourself with your money for the future, or you're paying someone else, but you have to do it repeatedly. Okay, any questions about the formulas? They look crazy, but your calculator can do all the work as long as you put the parentheses in the right place. The parentheses are going to be key. If you know anything about computer programming, you know that parentheses can change the entire outcome if you drop a parenthesis or miss one. Usually your calculator is smart enough and it can tell you, like, it'll tell you error of some kind, and so then you know that you're missing a parenthesis. All right, so let's try working with a couple of these. Can't spell. Each quarter, Sarah deposits $500. That's her own money, okay? Into a mutual fund. That's a type of investment or annuity. At 7.88%. Each quarter, that means every 3 months, she's making a deposit. 20 years late in the future, how much will she have? So 20 years from now, how much will she have? So hopefully the wording of this is clear to you, that this is a future situation. So you'll be using the FV equation. Okay, anything like 20 years from now, talking about the future, the fact that it's her own money, that it's an investment, all of those are clues to picking the correct equation. So the equation we want is FV equals R double parenth 1 plus r over k to the kt. The minus 1 comes at the end where you close it out with a parentheses, and then over the fraction r over k in parentheses. And so we're just going to drop the different numbers in. So we know that the repeated payment that Sarah is making is $500. So that's my R value. I'll have a double set of parentheses. 1 plus my rate, my little r, is the decimal 0.0788 over, now what's the k for this problem? What do you guys think? K is 4. Why? It's quarterly, okay? It's every quarter, and a quarter is 1/4 of something, and so this is 4 to the 4 again, and then times 20, because that's how much in the future we want to look. Minus 1. That whole thing is over the r again, which is 0.0788 over 4. Okay, so everything's just dropped into place where it needs to be. We don't have to do legal math to both sides because everything is in its right position. The only thing we have to do is practice typing that into the calculator. So grab your calculators, and this is just a practice to make sure that you get all the parentheses in the right place, and we all hopefully should come up with the same answer to see how much Sarah will have 20 years from now. Okay, so yeah, this works out to $95,483.39. So it's not too bad. I mean, $500 every quarter, that's about $150, a little more than $150, $175 a month. So if you could set aside $150, $175 a month, 20 years later, you have almost $100,000, okay, the way that it grows. So that's a pretty good investment. Okay, that's why, you know, you should say to your parents, how come you didn't invest money for me when I was born? Because now I'm 18 and I could have had this much money. All right, or you can make it a goal to do that for your kids as a gift to them. But yeah, the money really accumulates. All right, let's try another one. It works backwards though too, because if you borrow money and have to pay it back, you end up paying back a huge amount of money. So let's check that. Okay, so Emily pays back $815.37 monthly toward her student loan, and her student loan is at 4.7%, and she has 5 years. Okay, so she pays back that much money on her student loan for 5 years. How much does she owe? Okay, so this is student debt. It's very common for a college student to have to take out some money to finish paying for their schooling. Okay, I mean, there's other ways to do it too. Okay, going to a JC or a community college can really help cut down your overall cost if you transfer. But if you don't have savings ready to go for college and you got to pay for it on your own, then you might need to take out a loan. All right, so this is a loan. This is not her money. She's paying it back. And so this would be the PV equation, which is a different equation. So we have R, which is her repeated. The formula is this time is 1 minus, and then parentheses, 1 plus R over K to the negative KT. That negative is going to be important in a loan. Okay, just maybe you can remember, because it's not your money, it's a negative amount that you owe. So maybe that's how you could remember that the negative needs to be there, and then R over K. So for this one, the repeated payment she'll make is $815.37 times a parentheses that's 1 minus, and then another parentheses that's 1 plus. R is 0.047. K this time is 12 because this is a monthly amount. And then it's to the negative 12 times 5. That also needs to be in parentheses on the end. And then divide another set of parentheses by 0.047 over 12. Okay, practice typing that in and tell me how much Emily had owed on her student loan. $43,000 number, that should be correct. Read it to me again. 43 what? Okay. All right. So Emily owed $43,500-ish toward her college account. Okay, her college payment. And that's pretty typical for how much you might pay. Okay, all right, so let's try another one of this, and then I'm going to give you your very last formula. One more to go. Rob borrows, again, so not his money, $500 toward a house. $500,000 toward a home purchase, which wouldn't even really go super far in this area. You might have to move out to like the Riverside area or something to have that, be able to buy a home. He has 30 years to pay it back. Monthly. At 3.75%. How much will he owe each month? All right, so we know the total, but we don't know how much his monthly payment will be. Again, so not his money. Right? He's borrowing this money. And so this is going to be that PV equation again. So it's PV equals R, 1 minus 1 plus R over K to the negative KT, because this is not your money, and so it's negative, over R over K. So where does the $500,000 go? It goes in for PV. It's the total amount you're borrowing. It is not the R. I've seen students on their quizzes make the mistake of putting $500,000 in for R. What would that be telling me? That's how much they're paying every month. Okay? Nobody can afford $500,000 every single month. That's ridiculous. Okay? It's got to go in, the $500,000 has to go over in the PV side. We don't know what R is. That's what we're trying to figure out. We do know that he's agreed to a loan from the bank at 0.0375. We know he's got 12 months. It's negative 12 times 30 because he agreed to a 30-year mortgage. And then the whole thing is over the fraction 0.0375 over 12. The difference is we don't know R. And here's where R is, this is how you're going to solve this problem. We want to get R alone. And so sometimes you look at that and you're like, oh, there's so many numbers, there's so many decimals, there's so many parentheses, I can't even handle any of that. Okay, no problem. Just put a 1 under the 500,000 so that what could you do? You can cross multiply, which is going to take care of a lot of that for you. So 500,000 is going to cross multiply to the fraction 0.0375 over 12. Trust what you know about math. Okay, you know, even though it's intimidating for its numbers, and there's lots of parentheses, the math still doesn't change. We're going to cross multiply. And we just need to get r by itself. After we've cross multiplied, we need to get r alone. And so the way I get r alone is to divide by this huge mess. Okay, let the calculator do the work. Your job is just to type it in carefully. And so I'm going to take 500,000, which was cross-multiplied to the fraction 0.0375 over 12, and I'm going to divide it by this huge other fraction over 12 to the negative 12 times 30. Just have to use, and that will give me r by itself. Okay, that will give me r by itself. All right, so go ahead and type that in. I'm just really interested to know what you guys come up with for how much his monthly repeated payment is supposed to be. Actually, you know what? We'll save time. I'm going to do it. I figured it out already. 231558. He has a repeated payment of $2,315.58 every month. Okay, just out of curiosity, if that's how much he pays every month, how much will he pay in 1 year? What math do you do to figure that out? If that's his monthly fee. Multiply it by 12. All right, so let's take that number, 231558, and multiply it by 12. In a year, he's paid $27,786.96. That's in 1 year. But how many years does he have to do this for? 30. So how much will he pay in 30 years? So take that number and multiply it by 30. $833,608.80. Do you understand what's happening here? How much money did he borrow? Borrowed $500,000 of the bank's money. By the time he's done paying it back, how much will he have paid the bank back? $833,608.80. Who's getting the better deal? The bank. Because how much extra money are they getting paid back? $333,608.30. That's how the banks make their money. They're happy to loan you money because they know that you're not only just going to pay that money back, but you're going to pay them back a lot extra. So that $500,000 house ended up costing $833,608.80.